Use the probe mounting stand to hold the probe carrier in place while loading a probe into the tension spring clip. Use a pair of tweezers to lift the probe from the gel surface in the package and place it into the probe carrier. Place the probe into the center of the holder channel and allow it to slide toward the back. Then slide the clip forward over the probe chip to hold it in place. Loosen the locking screw and lift the head carefully out of the dovetail mount. Place the probe carrier onto the bottom of the dimension head by aligning the pins with the holes in the carrier. The dovetail mount assembly consists of the fitting on the back of the scan head and the complementary vertical channel on the stage. Slide the head back into the dovetail mount on the stage and fasten it in place with the locking screw. Take care when placing the head in the dovetail mount. If the fixture is not aligned, you could drop the head, causing severe damage to the piezo. There are two methods for aligning the laser onto the probe. Either method can be used to position the beam. The first technique involves projecting the laser onto a surface underneath the head and probe holder to observe the beam as it moves across the cantilever. The two knobs on the top of the dimension head are used to adjust the position of the laser onto the probe cantilever. On the left side of the head, there are two knobs to adjust the reflected beam onto the photodetector. Move the stage forward to allow room for the projected laser beam. Use a sheet of paper or any suitable surface to observe the projected laser spot. Align the laser onto the probe by rotating the positioning knobs until the beam is interrupted by the cantilever arm, creating a shadow. The second method is also a convenient way to verify that the laser is in the optimum position on the probe. The reflected image of the probe is located below the focal plane of the sample and is visible as long as the sample has a reflective surface. The position of the laser spot can be viewed in this reflected image. Use the software command Move to Alignment Station in the Setup screen menu to translate the stage forward. The station is located near the back of the sample chuck. This allows the probe to be placed above a reflective surface so that the image of the laser spot and the mirror image of the cantilever can be viewed at the same time. Lower the focus to see the tip reflection image, and then move the alignment knobs until you see the laser spot visible near the end of the cantilever. As the laser moves over the cantilever arm, the sum signal should start to increase. Rotate the detector adjustment knobs to steer the reflected laser into the position-sensitive photodetector. The window on the left side of the head reveals the position of the reflected beam. Typically, the optimum position will be near the center of the window. Occasionally, the reflected beam may be too far off center to show up in the window. It may be necessary to rotate the detector adjustment knobs all the way into their respective stopping positions and then rotate them back out one at a time until the spot reappears. The LCD screen on the stage and the software detector signal window will display the numeric value of the detector output. The intention is to balance the top versus bottom signal as well as the left versus right so that the laser is as close to the center of the detector as possible. This will result in the top, bottom, and left-right signals approaching zero. Once the position of the laser is optimized on the probe and centered on the detector, then you are ready to position the sample under the probe and initiate the approach process if you're in contact mode. If you're in tapping mode, you are ready to begin tuning the cantilever to its resonant value.